Hello students, in the previous class we have covered the riveted joints and the terminology used in the riveted joints. So we have discussed basic four terms. One is the pitch, second one is the transverse pitch, and third one is the diagonal pitch, and fourth one is the margin. This is the terminology used in the riveted joints we have discussed in the previous class. We have also discussed in the previous class the classification of the riveted joints. In the today's class, we are going to focus our study on the strength of the riveted joint. Strength and efficiency of riveted joint. So this is the first plate. This is the second plate. This is the row of the rivet, and this is also the row of the rivet. This is the force coming on this joint. P is the force over here. So P is the force. So how much force the joint can sustain? How much force the joint can sustain is known as strength of the joint. Strength of joint. How much maximum force? How much maximum force the joint can sustain is known as the strength of the joint. So this is the joint. This is the joint. There is a cover plate which is required. And a cover plate may be at the top, cover plate may be at the bottom or at the both places. So this is the top cover plate and this is the bottom cover plate. This is the top cover plate and this is the bottom cover plate. So this is basically butt joint. So it is a butt joint and it is single riveted. And when you will see the top view, then you will be able to find that it is a chain system, it is a chain riveted or the jig chain riveted, whatever. So it is a butt single riveted. So force is coming P. Due to this force, there may be failure. So failure may be shear of the rivets. Shear of the rivets. So first I draw the top view. So I extend this line. I am extending this line also. This is the rivet in the first row. These are the rivets. Similarly, these are the rivets. So due to this force, the rivets can fail in shear. So this is the shear area. So shear area for rivet is pi by 4 d square, where d is the diameter of the rivets. So due to this force, the rivets can fail in shear. The plate can fail in tensile failure of the plate, or rivets can fail in the crushing. If the rivet material is weak, then rivet will fail. If the plate material is weak, then plate will fail. So any one of them can fail under crushing. So these are the three main failures in the riveted joint. One more failure is there. Failure of the plate at the margin. Failure of plate at margin. So let's consider one by one. So I will write the strength equation. So first case is shear. So for the shear failure, total force is given by area multiplied by stress. Area multiplied by the stress. Force is given by area multiplied by stress. So force is P, area is pi by 4 d square, it is the area of one rivet. But there are so many rivets, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 rivets in this system. There are 8 rivets in this system, you can see. There are 8 rivets in this system. So let n is the number of the rivets. So this area will be multiplied by n. So n is the number of rivets used in the joining of the plates. And the total number of the rivets. So n times area pi by 4 d square multiplied by stress. It is a shear stress. Let the permissible shear stress is tau. Tau is the permissible shear stress. So P equal to n times pi by 4 d square into tau. This equation can again be modified. This equation can be again be modified as per single and double shear. As per single and double shear. So because two cover plates are involved over here, so this is a case of double shear. So this is an example of double shear. I am drawing an example over here that this is first plate, this is second plate, and that this is the cover plate on the top, there is no cover plate at the bottom, and there is a rivet. So this is an example of single shear. So if this is the equation for single shear, if our case involves double shear, when system involves double shear, then area has to be again multiplied by 2. So P equal to twice n pi by 4 d square multiplied by 10. So this is the equation. Sometimes it is observed as per the pattern that some rivets are in single shear and some rivets are in double shear. That I will show you the example in which some rivets are in single shear and some rivets are in double shear. So let I am taking an example. So let this is a first plate, this is the second plate, again butt joint. Let this is the cover plate. So top cover plate is small and bottom cover plate is more long as compared to top cover plate. So width of the cover plate or length of the top cover plate is small and length of the bottom cover plate is more. So let it is the case of triple riveted. So let this is the first row. So first row, there will be shear, this point will again have shear, so it will be double shear in the first row. Let this is the second row. So again it is a double shear in the second row, and let this is the third row. So this row claims the plate number 1 and the bottom cover plate only. It does not involve the top cover plate. So that's why it is a case of single shear. So in the third row, it is single shear. In the first and second row, it is double shear. So this is a combination, this is example, is a combination of the single shear and the double shear. So now, let there are 5 number of rivets in the first row. There are 5 number of rivets in the first row. And there are 4 number of rivets in the second row, and there are 3 number of rivets in the third row. So how will you write the strength equation for this example? So your strength equation can be written, again you are having force, force is P over here. So force is area multiplied by stress. stress is tau. Tau is the permissible stress. Tau is the permissible stress. Now what is the area? These three rivets are in single shear. Three rivets are in single shear. 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 rivets are in double shear. So let N1 is the number of rivets in single shear. In our case it is 3. It may be any value, but in our case it is 3. And N2 is the number of rivets in double shear. In this example it is 5 plus 4, that is 9. It may have any value. So N1 are the number of the rivets in single shear. So I will write N1 multiplied by 5 by 4 d square. It is the area of N1 rivets in single shear multiplied by permissible stress plus N2 number of the rivets in double shear, so it is multiplied by 2 pi by 4 d square, diameter is common, multiplied by permissible stress. So this is my stress equation. So I can take pi by 4 d square into tau common, so it is N1 plus twice of N2 multiplied by pi by 4 d square into tau. So this is the final strength equation for this exam. Okay, so just understand the concept. This may be the equation, this may be the equation, this may be the equation. Depends on the example. What is the structure of the rivet? Just find how many rivets are in single shear, how many rivets are in double shear, and just use the strength equation. So this maximum force that our rivet system can sustain, it is the strength of that riveted joint. Clear? So shear failure is now over. Now I am coming to second failure. So second one is tensile strength. Tensile strength of riveted system. So how will we find? Again the force is area into stress. Now what is the area? What is the stress? So now see, this is the row of the rivets. I am extending this. Let this is having this rivet, this rivet, this rivet, this rivet. Let there are 4 rivets in this row. In this row, let I am using the chain system. So this is again having 4 rivets. Rivets are just opposite to each other. So this is the chain system. We have discussed in the previous classes. Now this is the third row. Again, rivets are just opposite to each other because our system is not zigzag, it is chain system. So what will I do? This distance, pitch. This distance is pitch. So what is my area? Let this is the plate. So the width of the plate is W. So it is W. From here to here it is W. It is W. Correct? Now, due to the force is P coming over here. So due to this force, the plate may break from here. It can fail from here. From these points it may fail. So what is this area? Total width is W. You have to subtract D from here, D from here, D from here, D from here. So D plus D plus D plus D, it is 4D. So your equation is W minus 4D. It is the width from where the plate is under tensile stress due to this force P multiplied by the thickness of the plate. So let the thickness of the plate is T. T is the thickness of plate. So W minus 4D into T is the area multiplied by tensile stress, let sigma T. Sigma T is the permissible tensile stress, and this will equal to the force, so it is the strength equation under tensile failure. Let number of the rivets are not 4, number of the rivets are n. So what is my general equation? It will be W minus ND into T sigma T. I can generalize this equation. So W is the width of the plate, N is the number of the rivets, D is the diameter, number of the rivets in one row, or you can say outer row. D is the diameter, T is the thickness, sigma T is the permissible tensile stress. So P equal to this much. So this part is now over. One more important point is here. Sometimes in questions, W is not given, width of the plate is not given, only the pattern is given. Only the pattern is given, but it is not given width of the plate. So you do not know how many rivets are used in the total width of the plate. So in that case, when we design the rivet system, we do the per pitch calculations. This is the first row, second row, third row. So in that case, what will we do? We will do the per pitch calculation. So this distance is pitch. So this is the per pitch calculation. So in this pitch length, you see, in this pitch length, how many rivets are occupied? In this pitch length, how many rivets are occupied? So you see over here, the half rivet is here. This is the half rivet. Half rivet is here. Half rivet here in the second row. Half rivets again in the second row. Similarly in the third row, half plus half. So you see, half rivet here, half rivet here, half rivet here, half here, half here, and half here. 6 halves. 6 times half, it will give you 3 rivets. Half plus half plus half plus half, 6 times. So it will give you 3 rivets. So we consider per pitch calculation. So number of the rivets are 3. Number of the rivets are 3. So my shear strength equation will be P equal to 3 multiplied by pi by 4 d square. It is the area of one rivet multiplied by 3 rivets. Let a case of single shear. If it is double, then it will be again multiplied by 2 multiplied by tau. So this will be shear strength equation. Suppose I have to, due to the force, the plate is breaking from here. And under tensile force, the plate is failure from here. So what is this length? The total length is P minus this length half D, this length half D. So P minus half D minus half D. So this will be P minus D. So this length is P minus D. So your tensile strength equation will be given by P equal to P minus D into T sigma T. So this will be the tensile strength equation for per pitch length. Per pitch length. So when the width of the plate is not mentioned in the questions, in the numericals, then we have to design as per the per pitch length criteria. Okay. So P equal to P minus D into T into sigma T. So this is the tensile strength equation. Now I am moving to third, last one. So that is crushing failure of the rivets. So what is the crushing area? As usual, what is the crushing area? So when you will project it, so you will find a rectangular in which the thickness of the plate and the diameter of the rivet. So this is the crushing area. It is the crushing area, crushing between the rivets and the plate. So rivets and plates are in contact with each other. So that contact area is a rectangle having length equal to diameter of the rivet and width equal to thickness of the plate. So dt is the crushing area of one rivet. So what is the total crushing area? So total crushing area is given by n times dt. Crushing area of one rivet is dt, area of rectangle. So it is n times dt, n is the total number of the rivets. So my crushing strength equation, which equation I am writing now? Crushing strength equation. Crushing strength equation. So crushing strength equation given by force equal to area into stress again, same logic. Area into stress. Now area is ndt. Ndt is the total area. Stress is the permissible crushing stress, that's sigma c. So P equal to ndt sigma c is the crushing stress. So my joint is having three main important strengths. One is the PS, which is the shear strength. One is PC, which is the crushing strength, and one is PT, which is the tensile strength. The minimum of these three, the lowest of these three, the lowest of PT, PS and PC is known as strength of the riveted joint. Final strength. It is the final strength of the riveted joint. Lowest of these three. If I want to calculate the efficiency, eta, so eta is given by lowest of PT, PS and PC divided by strength of solid plate. Due to drilling for the rivet holes, the strength of the solid plate is reduced. So in the denominator we are taking strength of the solid plate, which is bigger value, and lowest between PT, PS, PC, which is a smaller value of these three. So this is the efficiency of the riveted joint multiplied by 100 if trying to convert it into percentage. So this can be written as lowest of PT, PS, PC divided by strength of the solid plate is given by PT sigma T. Suppose there is no hole. This is the rivet number 1, rivet number 2. This is the pitch length. And suppose there is no hole, then this is the value of solid plate. So what is the length for the solid plate per pitch? It is P. So P times T, P into T, T is the thickness, into sigma T is the permissible stress. So PT sigma T is the strength of the solid plate. So when you will divide it and multiply it, then you will get the efficiency. So in the today's class, what we have covered? We have covered different strength equations. What is the different area and different situations, and what is the efficiency of the riveted joint. And this ends this lecture. Thank you very much. Thanks for listening. Stay home, stay safe. Thank you very much.